So the same types of questions I asked you in the growth and the decay graphing, you're going to be asked in this as well. So when you look at this, can you identify whether this is, well, first of all, let's take a look at just the graph of y equals e to the x. And what's this general graph going to look like? A growth model or decay model? Is e a number whose absolute value is less than 1? No, it's 2.7, right? So it's just like having a base of 2 or 3 or whatever. It's a growth model. So your general graph is going to look like this, and all of the rules that we follow for the graphs will apply. So when you look at this equation right here, so is it growth or decay? Growth, because the power or the sign of our power is positive. So this is a growth model. Okay, what would be the shifting that occurs on this graph? The horizontal shifting goes which direction? Left 1. And the vertical shifting goes down 3, right? So we're going to take our asymptote, 1, 2, 3. We have this horizontal asymptote here of y equals 3, negative 3, okay, based on our vertical shift. Okay, so that's another piece of information that you can find. Okay, we have our shifting. So we can sketch our graph. It goes down 3 over 1. Is there any reflection? No. So our graph's going to look like this. Okay, the 4 out front means, are we stretching or shrinking? When the multiplier in front, okay, so there's no reflection. This is stretching it. It's going to be a little bit higher, but a small bit. Okay, and then what is the behavior of this graph? Is it up and to the right, up and to the left, down and to the right, down and to the left? Remember I talked about this yesterday. And so even though as this moves to the left, it is getting lower and lower, but it has a specific limiting point. So we're not going to describe this as down and to the left. We're going to describe it as up and to the right. Okay, so all of these tendencies are based on that equation. Now, there's one new thing that you're going to see here regarding these tendencies, and it'll be modeled here in this other example. Okay, what if I take this equation here? All right, so what did I do in this one that's different than any other graphs that you've seen, for those of you who pay attention? Josh? Yeah, so there's a multiplier in front of the variable now, right? So you haven't seen those yet. Okay, what that's going to do is it's going to steepen the graph. Okay, so the stretch and shrink is the multiplier out in front of the whole function. Okay, so is there a multiplier in front of this function? No, so if I ask you, does this stretch, shrink, or neither? Neither. What about this one? Stretch. Now, if I ask you, is it steepened or flattened? Okay, if this multiplier, again, disregard the sign, because the sign has to do with a different relationship. So if you just look at the absolute value of the multiplier, if that value is greater than 1, it steepens the graph. It just means that this graph is going to grow exponentially, even at a faster or steeper rate than it would if that was just the exponent x, right, the power x. So a multiplier in front steepens it. If this multiplier in front happens to be a number whose absolute value is less than 1, so it's a fraction like 1/2 or 0.5, then it's going to flatten the graph. Okay, so this number right here will steepen if the absolute value is greater than, or let me write that with ABS. Okay, so if the absolute value is greater than 1, it's going to steepen. If it's less than, If the absolute value is less than 1, it's going to flatten the graph. Okay? So now when you look at this, can you identify whether this is a growth or decay model? Okay. Yeah, good. So remember, there's two things that identify decay. Okay? The first is, and probably the easiest one is if your base is a value, again, whose absolute value is less than 1. So if you apply the properties of this negative power, what is our base actually going to be? The negative power makes our base 1 over e, right? So really this graph, if you were to rewrite it without the negative power in it, looks like this. It's 1 over e, which is a value less than 1. Okay, so it's going to be a decay model. So this is decay. Okay, are there any shifts that are occurring here? Horizontally, what shifts occur? None, right? It's just the steepen. It's not going to shift at all. And so what vertical shifts are occurring? Up 1. Okay, so that means our horizontal asymptote is at y equals 1. And so again, if I kind of look at this graph, remember what the model for decay looks like. Looks like this. Okay, so here's our decay model. And so we're going to shift this down 1. And so here's, oh, I'm sorry, up 1. Oops. Is it connecting back onto your guys' screens? I know. All right, so we can set our horizontal asymptote at y equals 1. Okay, so the graph gets shifted up, and it's a little bit steeper. So that just means that it gets higher, faster. There's no other shifting that occurs. And so as far as the negative power, okay, the negative on the inside of this would take your exponential growth graph, and it would reflect it across the x-axis. I'm sorry, the y-axis. So the negative here would take this growth function and reflect it across the x-axis. But as far as the decay function, it's just the normal decay function. There's no reflection occurring on that. And again, the easiest thing to do is to just rewrite the negative power in the form of the inverted fraction, 1 over whatever that base is, in order to see what you have. Okay, so there's no stretch or shrink, but there is a steepen because it has the multiplier up in that power.